I give you Dr. Christine Hendren.
Thank you so much, Karen. That was really nice. We're thrilled to have everybody here. And as you all know, the reason you're calling in probably today is because we are extremely fortunate to have Professor Dan Stokols visiting today. He's going to talk about transdisciplinary multiscale theorizing and research aimed at better understanding and ameliorating some of the most pressing societal and global challenges of the 21st century and foreseeable future. Dr. Stokols is a Chancellor's Professor Emeritus of Social Ecology in two departments, the Departments of Psychological Science and of Urban Planning and Public Policy. He's also the founding dean of the School of Social Ecology at the University of California, Irvine. And he that was one of the many ways that he has kind of found So I'm thrilled to hear all of the things he's going to bring to us today, including some of the seminal ways that he helped found the Science of Team Science work and the evidence basis for the group that has brought all of us together. So we're thrilled to have him here today. His research is focusing on the study of people's transactions with their social and physical environments, and particularly how those transactions and the people influence personal and public health. Through this field, he has served as a really instrumental guide and contributor to the science of team science, the ideas of convergence, transdisciplinarity, and all of the things we all care about. So with no further ado, welcome to Professor Stokols, and thank you so much for joining us.
Thank you, Christine. I appreciate the kind introduction. And at times the audio seemed to delay a little bit, so if you have any trouble hearing me as I speak, feel free to call me on my cell and we can switch it over to phone audio. Right now it's computer audio, but it should be okay. I'm going to switch over to slideshow mode and basically wanted to share with you some thoughts I have about multi-scale approaches to sustainability and other major challenges facing us in the 21st century. And let's see, I'm trying to advance, there we go. So I know that at times in the Interreach sessions, career development comes up, and I wanted to say a little bit how I got into the field I'm in. I thought I was going to be a marine biologist. This is me in high school, and the school paper did some articles on graduating seniors, and I was doing this internship with my high school mentor, marine biologist Howard Lenhoff. And it was a very exciting introduction to science. I did an experiment, wrote it up. And as chance would have it, Howard and I met up at UC Irvine. When I came as an assistant professor, he was here as a biological sciences professor. And so we worked together at UCI for many years after that, even though at the time I went off to college at the University of Chicago and was exposed to a variety of other fields in college that I really was excited about: social sciences, urban planning, anthropology. Chicago had a great general education program that emphasized interdisciplinarity. And after that, I went to University of North Carolina, Chapel Hill to study social psychology. And I got my PhD in that field, but I still had a hankering for sort of community macro level kinds of fields. So I took minors in city planning, sociology, and did work in public health. And which was a little odd at the time in the 1970s, where the coin of the realm was specialized science in a particular field. And I had these kind of mixture of interests. And then I got a call from UC Irvine that I was on their short list. I didn't realize I was on their short list for jobs because I hadn't applied there. But it was a very new campus and they were growing quickly, and they had assembled a list, and I had written an article on crowding that they were interested in. So they called me and asked me if I want to come for an interview. And my advisors thought that was not the greatest place to go for a social psychology student. They thought this newfangled social ecology program might be a mistake. And I had some misgivings about it too, but after I went out for the interview, I kind of got hooked because it was a very exciting new venture. a lot of sort of risk-taker faculty who wanted to develop an interdisciplinary, ecologically grounded, translational kind of program, research to practice. So that's where I decided to go. I thought I'd maybe stay a few years and go somewhere more traditional, and that was about 45 years ago. I'm still at UCI. So Christine asked me to mention a little bit about the book that I recently published on social ecology in the digital age. And in that book, I talk about my journey in the first chapter, how I found my way into the field of social ecology. And I also look at sort of the historical and conceptual foundations of the fields of biological ecology, studying how organisms relate to their environments, and looking at plant and animal biomes over extended periods, the work of people like Haeckel and Clements and Darwin in the 1800s, which was later picked up in the early 1900s by the sociologists at the University of Chicago, the Chicago School of Human Ecology, where they were looking at how behavioral disorder and diseases were spread across urban areas like the city of Chicago, and found a kind of interesting set of gradients of degree of severity as one moved from the center of the city out to the suburbs and more affluent areas where some of these problems were less. So they put a lot of emphasis on geography, economics, and the biological analogies of the work of people like Darwin. Some people referred to the Human Ecology School at Chicago as sort of a social Darwinistic approach to ecology, because it left out things like environmental injustice, law, legal institutions, regulatory strategies to improve the fit between people and their environments. And this is an early concentric zone diagram from the Chicago School showing rates of disorder over a period of time there. And the field of social ecology grew out of some of those early efforts to provide a broader purview, a more transdisciplinary approach where fields like psychology, anthropology, urban design got factored into the people-environment equation. It wasn't just a matter of economic adaptation to a geographical space. So the field has grown very rapidly, actually, in the last 10 to 20 years as people have become more and more attuned to ecological thinking about sustainability issues, urban pollution, and some of the other problems we're facing: poverty, war, inequality. And we know that people not only are affected by their environments, but they have a very heavy impact on their surroundings as well. So social ecology emphasizes that kind of transactional relationship between people and their surroundings. And in the book, I derive some core principles that I believe go across these different approaches to ecology, from the biological, the human ecology, to various schools of social ecology. And then I apply those principles to various problem areas, such as promoting personal and public health, analyzing complex social problems, managing global environmental change, designing resilient and sustainable communities, and also educating the next generation of transdisciplinary scholars. So those are some of the things that happen in the book itself. One of the problem areas, of course, is sustainability that I talk about in the book. And if one looks at how societies have related to nature throughout history, about 12,000 years ago, with the arrival of the Holocene epoch in geological history, people began to settle into into farming, and rather than just their nomadic lifestyle, they became much more agrarian. And that has led to a variety of our industrial agricultural approaches in the 20th and 21st centuries. But this tendency to settle down and become more agrarian really started about 11,000, 12,000 years ago. And much more recently, with the start of the Industrial Revolution in the 1700s, and then even more recently than that, from the 1980s on, we had the digital revolution. And it's these two later shifts in how people relate to nature, especially how societies as a whole relate to nature, that have led to our current concerns about sustainability, the arrival of the Anthropocene, where people are seen as dramatically affecting not just the regional quality of their environments, but the Earth system as a whole. So we have this growing recognition of sustainability threats, which began to impinge on our awareness in the late 20th century. The Anthropocene is the period marked by substantial human impact on the Earth system. It's a term that was first used by Crutzen and Stormer in 2000. And we've seen a shift as we look at people's impact on the environment from kind of a regional or even national focus, such as Rachel Carson's work on the Silent Spring, where she drew attention to the public health hazards of pesticides and other synthetic chemicals, to a much more global perspective now on how people are able to affect the Earth system. And some of those early studies actually happened at UC Irvine, where a group of scientists, Sherry Rowland, Mario Molino, were studying the process of ozone depletion. And they were nuclear chemists. They weren't really interested in atmospheric chemistry, but they happened to go to a meteorology conference as something different to do after Sherry Rowland stepped down as being chair of the chemistry department. And he met a fellow named Lovelock who told him about this buildup of chlorofluorocarbons in the polar regions of the Earth. And Molina and Rowland went back to their labs and started to theorize, well, what would happen if these inert CFC molecules produced by humans, for repellents and sprays and refrigerants, if those wafted up to the stratosphere and were hit by ultraviolet light, how would those affect the ozone layer? And they found that, in fact, these chlorine atoms, when they're hit by the ultraviolet light as part of a CFC molecule, break off, and they combine with ozone molecules, O3, to form two oxygen molecules, O2. And it sets up a chain reaction where a single CFC could destroy hundreds of thousands of ozone molecules over a period of 50 to 150 years. So it was a very major problem in their view, and they began to draw attention to it. And in fact, in 1995, they won the Nobel Prize in chemistry, along with Paul Crutzen, who was studying the effects of nitrous oxide on ozone depletion. But their work initially was not taken very seriously. It was seen as alarmist. A lot of companies that were in the business of producing CFCs pushed back. There were calls to our chancellor to fire these guys because they were putting out quack science. And the National Science Foundation, National Academy of Sciences convened panels to study this process, and they found, in fact, that the calculations that Molina and Rowland had were quite accurate, and it was a huge problem. So eventually, in 1984, this big hole in the ozone layer was discovered by Farman, a British researcher over Antarctica. And with that graphical image, the world really started to take this seriously. And within a few years, late 1980s, the Montreal Protocol was introduced. It's been one of the most effective international environmental treaties ever enacted because it's actually helped to heal the ozone layer. We're not out of the woods entirely, but it really has made a big difference in banning a lot of these CFC molecule production. They still happen around the world illegally. You can't control the flow of those into the atmosphere and the stratosphere entirely, but the regulation has made a huge difference. Now, another aspect of people affecting the Earth system is with respect to carbon dioxide levels and global warming. And this is Charles Keating, who at the Scripps Institute of Oceanography in La Jolla began to build on others' work about the possibility that certain gases like CO2 and methane can actually create a kind of greenhouse effect, trapping heat. The sunlight that comes to the Earth and is reflected back as infrared heat that's trapped by these gases. So he set up a testing station in Hawaii, which was far away from urban areas and from tropical forests that would affect the uptake of carbon dioxide. And he began to take these measurements of CO2 each year. And these are his data from 1958 to 1972. And you can see the steady rise in atmospheric CO2 parts per million And there's an up and down pattern here, and that's because it's kind of the Earth breathing in and out CO2 during the summer months. As vegetation becomes more prominent, it absorbs CO2. During the winter months, the CO2 level into the atmosphere goes up. So you have these cycles up and down. But the general trend was an increasing trend of greater CO2 emission into the atmosphere. So this was problematic, to say the least. And if you look at Keeling's data, which are on the far right of this graph, and you can look at these changes every week, actually, if you go to the Keeling curve website. And this is a reading back in May 2018, where the level was 412 parts per million CO2. And what these data are out here 800,000 years earlier are based on ice core data, where carbon dioxide bubbles in the ice cores are analyzed for their concentration in the atmosphere. And those have barely gotten over 300 parts per million. So this rise in the last 100 years or so has been extreme. And we've crossed the 400 parts per million threshold, and we're increasing each year, actually, the amount of carbon dioxide in the atmosphere. And what's happened is during the late 20th century, there was a phase called the Great Acceleration, where after World War II, there was a tremendous uptick of economic growth and investment, population growth, urban populations expanded, energy use, fertilizer consumption, water use, dams were constructed. So this is referred to as the Great Acceleration, and that's all well and good. It led to a lot of economic prosperity and millions of people being lifted out of poverty. But it created a kind of aftermath in the late 20th and early 21st centuries, where what we've seen as a result of this zooming of our economy and fossil-based economy is the rise of carbon dioxide, nitrous oxide, methane, other greenhouse gases, loss of stratospheric ozone, the rise of the Earth's surface temperature, ocean acidification, etc. So these are kind of showing the aftermath of that Great Acceleration. And these are data published by Stefan and others at the Stockholm Resilience Center. They've done some of the best work on the Anthropocene and quantifying its impact. But if you look at 1950 to present, that's when things have that's where the Anthropocene is thought to have begun, because there's such a dramatic uptick in these impacts, humans' impacts on the Earth system. Now, Stefan Rockstrom and others at the Stockholm Resilience Institute have also theorized that and have begun to measure 9 different planetary boundaries. For example, the levels of climate change that we can sustain and still maintain the biosphere intact. The levels of genetic diversity and functional diversity, or biosphere integrity, that we can sustain while keeping the biosphere healthy. Biochemical flows of nitrogen and phosphorus, which have been changed radically by our industrial farming techniques. All of these things, land system change, the damming of our rivers and the modification, clearing of forests for urban areas. At least 4 of those boundaries are now thought to be beyond the zone of uncertainty, or in a zone of uncertainty, and sort of potentially dangerous for the Earth's future. And then some of the other boundaries haven't been accurately or precisely measured yet, like atmospheric aerosol loading. But we know that ocean acidification is increasing with greater CO2 emission into the atmosphere. So this is a glimpse of how people have changed the Earth system in a very relatively short period of time. Now, when we talk about sustainability issues and impacts on the Earth system, it's not as if everybody is being affected equally. So there are a number of geographic factors that affect people's sensitivity to climate change. If you happen to be living on a low-lying island, or in an area, a river delta, which is susceptible to flooding, or in a very arid desert area, those are geographic risk factors. Those are some of the most sensitive areas to climate change in the near term, although the Earth as a whole is feeling these changes collectively. There are also demographic predictors of sensitivity to climate change. Impoverished women, children, and elderly, and the infirm are the most vulnerable to the near-term effects of climate change. And so our notions of sustainable development and sustainability have had to shift from sort of a generalized view of whether the current generation is using too many resources relative to what future generations are going to need, to accommodate much more socio-demographic aspects of development. So here you have the Brundtland Commission view of sustainability in 1987, which emphasized intergenerational equity, development that meets the needs of the present without compromising the ability of future generations to meet their own needs. But this book by Jeffrey Sachs and other more recent analyses of sustainability emphasize several other dimensions of sustainability beyond preserving our natural capital and biosphere: economic prosperity, social inclusion, gender equality, societal cohesion, good governance processes. So these now have to be taken into our notions of sustainability. It's a very much more transdisciplinary view of sustainability than our early notions of what sustainability meant. Now, in this book I mentioned, I take certain core principles that seem to be common to many different approaches to social ecology and human ecology, and I apply those to issues like sustainability and other problems like public health. And one of those principles is that our interactions with our surroundings happen at multiple levels, and they're nested within bounded environmental contexts. So our homes and workplaces are embedded in communities, which are nested within larger regions and nations. So these different contexts of our everyday life go across geographic, social, and temporal scales. So in the field of the ecology of human development, one of the foremost theorists, Bronfenbrenner at Cornell, noted that if we want to understand a child's development, for example, we need to know more than just how that individual's family microsystem, their home, their parental relationships, how that affects them. We have to understand mesosystems, or how the family and the home is connected to the child's school and what goes on there, and the parents' relationships with the teachers, and also what happens in the neighborhood and the peer microsystem. So all of these different mesosystems that the child is embedded in affect his or her development. And then in this outer level, you have what Bronfenbrenner called exosystems, which are settings that affect the person's development, but the person isn't directly participating in those settings. So the parent's workplace would be a kind of exosystem, because the parent brings home resources, or may bring home stress or worry from the workplace, whatever, that affect the child, but the child is not actively in that setting. And then Bronfenbrenner also noted that we have to take account of the macro system, the broader socio-political, cultural context and mores that impinge on a person's development. So it's a very multi-scale kind of approach to human development, which was very new at that time for Bronfenbrenner, because most human development theories focused on more narrow, isolated settings and how they affect developmental outcomes. Well, if we apply that kind of multi-scale thinking to sustainability, we see some of the same principles applying, that you can try to improve or enhance sustainability at the global international level through treaties like the Montreal Protocol, Sustainability Development Goals, the Paris Climate Accord. But if you want those 30,000-foot level interventions to be effective, they have to be combined and integrated with interventions and initiatives at lower levels. For example, smart city infrastructures and municipal and state and national regulations, clean air and water quality regulations, or a city's ban on plastics, or carbon cap and trade. And then if you go down a level further, we're talking about behavior settings like homes, neighborhoods, workplaces. Does a manager of a workplace implement sustainable business practices, or do homes incorporate solar energy capacity? And then even at a lower or ground level, we're talking about individuals and whether they have certain values or lifestyles that are conducive to sustainability? How do we educate people to have those kind of values and lifestyles? So we really have to look across these different levels in order to understand sustainability more thoroughly. And sometimes analyses of sustainability tend to focus at one or another level, but not pull them together as much. So that's part of why we need, much more of a multi-scale approach to not only analyzing sustainability, but promoting it through interventions. This is an example of an international treaty, the United Nations Sustainable Development Goals, which run from 2015 to 2030. And you can see in these goals the range of issues that come up when we talk about sustainability in terms of gender equality, equal access to education, reducing inequality across countries. So there's a lot of that social and cultural emphasis in these regulations. The problem is these aren't assured of being effective just because people have signed on to them. For one thing, we have a lot of movements around the world that deny climate change or that it's human caused. And so those kind of values and beliefs are working against these kind of sustainable development goals. A country can pull out of the Paris Climate Accord, as our country did recently, last June, or about a year ago. But that doesn't mean that other things can't happen at these other levels I mentioned. So, for example, the private sector is stepping up in coming up with much more advanced renewable energy technologies. And global renewable energy in 2015 overtook coal for the first time as the world's largest installed power source, and driven largely by the growth of solar and wind power, and as well as some of these other kinds of renewable energy. So that's one kind of compensating factor. It's not just all about government regulations and international treaties. It's also the case that to achieve sustainability, we have to look across different levels. So we can look at these very broad national civil infrastructures for energy and agribusiness and the water sector. But to really enhance resilience, those need to be connected to more localized, alternative, decentralized kind of technologies like residential solar, urban farming, home water capture. And these enhance resilience because they add to the capacity of the system as a whole. So if there's an earthquake or if there's a cyber attack and one of these large-scale civil infrastructures goes down for a while, these localized resources can compensate. That's another example of thinking across these different scales in order to create a greater impact on sustainability. Some cities are very good about providing urban infrastructures that promote sustainable behavior. And you see this, this is Zurich, for example, where there's a tremendous emphasis on biking and non-automobile transit, trams, and the train system, which is extremely well developed there. And it enables people to behave sustainably because they have this infrastructure all around them. So that's another facet of looking at sustainability at that level. Public policies, municipal and state policies. For example, Seattle's ban on plastics. We have in Irvine, as many other communities do, neighborhood recycling programs. In California, within a year or two, all homes that are constructed in California must incorporate solar energy technology. So that's a state level regulation that's going to make a big difference combined with some of the more international regulatory treaties. And then at the ground level that I was saying, how do we educate people for greater eco-literacy and get residents and children to participate in environmental stewardship programs, or encourage individuals to adopt electric vehicles or home energy systems where they can store solar energy. So these are things that individuals can do at that lower level. Also, institutions can invest in solar energy. These are a couple of strategies at our campus where solar panels are prevalent all over the campus, especially on tops of these parking structures. So you've got a parking structure, but at least it's being used to harvest a lot of renewable energy. And you've got this bus system. Our mascot is the Anteater, so it's called the Anteater Express. But these are all electric buses now. So these are things institutions can do. So that's one kind of principle that I wanted to emphasize, this sort of multi-scale look at vexing problems like the Anthropocene and sustainability. Another core principle that I talk about in the book is the multidimensional structure of human environments, which include natural, built, sociocultural, and virtual facets. And some of these are directly observables, and some of them are more subjectively perceived. They're not immediately observable. This is a sort of hypothetical human community where you've got homes and workplaces nested within a broader region, and you've got the natural environment, the built environment, the cyber. And when you break those out, you have these 4 spheres of environmental influence. And much of ecological thinking has been focused on the first 3. People's interrelations with the natural environment, the built environment, the sociocultural environment. What I've tried to do in some of my recent work and in the book is to build in the cybersphere as a 4th arena of environmental influence that dramatically affects people's health, their behavior, their development, and the sustainability of their environments. And in the future, there may be other spheres of environmental influence. For example, when we start to travel frequently in outer space, we'll be exposed to environmental influences that we can't even anticipate right now on Earth. So there may be another realm of interplanetary environmental experience. But for the time being, I look at the interface among those 4 environmental spheres and how they affect various health, behavioral, and sustainability outcomes. And you can see this merging of these different spheres in this picture from a Chinese village where they've used the natural environment to literally grow a quick read code so that people flying over that village can take a picture and find out all about the tourism possibilities there. They're encouraged to visit. So in that one diagram, you've got the natural environment, the built, the sociocultural aspects of tourism, and the cyber in terms of this quick read code. So it's a very interesting fusion. The cybersphere is quite diverse, and I use it to encompass a broad array of technological strategies. So some of those include computers, servers, routers, Ethernet, Wi-Fi, the deep web, the World Wide Web, the dark net, cryptocurrencies, blockchain, Bitcoin. Also our mobile phones and other devices that send and receive messages in various media. Browsers, search engines, social media, cell phone apps that people use to access products and services, recreational resources, education, health-related information, virtual communities. The sharing economy, whether that be Uber, Lyft, Airbnb, the Internet of Things, all the ways in which different appliances and equipment are interconnected without human mediation. They all have internet sensors and they stream data to each other. And pretty soon there's going to be upwards of 1 trillion different objects interconnected to the Internet of Things. And that has tremendous implications for sustainability that I'll talk about later in terms of energy consumption. Augmented and virtual reality, 3D printing, GPS navigation, autonomous vehicles, smart cities. So all of these are part of the cybersphere, and I use it in a very broad way. And I'll explain a little bit more why I do that rather than just focusing on the internet per se or just focusing on virtual reality per se. But this is kind of what makes up the cybersphere. And I also see the cybersphere as being having a kind of spatial scope in a sense, in that the near cybersphere are all the cyberspaces that we're aware of in our day-to-day life. So from my home or office, I'm connected to the Zoom session. Or if I'm a professor in a classroom, I can bring in online resources that reinforce my lecture. So that's this positive kind of relationship between the place-based setting and the virtual setting. If I'm on a beach reading my email and it has really little implications for anyone else there or my own well-being, there's kind of a neutral relationship. But if I'm a supervisor in a workplace and an employee is recreationally surfing Facebook, that may be negative in the sense that the supervisor could decide, well, this person's goofing off, they're not living up to what they're supposed to be doing in the place-based setting, they're more involved in the virtual setting. So these are cyberspaces that we access from a particular place. I call it a real virtual mesosystem because it's two settings, one real, one virtual, connected. And anytime we access a virtual connection or send a text message or whatever, we're doing it from a particular place. But then there's the distant cybersphere. And these are aspects of cyber technologies and transactions that we are not aware of on a day-to-day basis. A lot of the GPS signals that go between the 31 GPS satellites circling the Earth and our cars or our cell phones, we're not immediately aware of those. They'd be below awareness. The dark web, there's all kinds of hacking and child trafficking and all kinds of other things that go on the dark web. We don't see that, but it's happening. The Internet of Things, all these connections between different objects that we don't see. And these are very relevant to human well-being and societal well-being because they could bring down, if hacking on the dark web could bring down a whole civil infrastructure or an electrical grid. There are all kinds of ways that these have implications for our health, behavior, and sustainability, but we just don't see them. So I make this kind of distinction between near and distant regions of the cybersphere. And just to give some examples of that jargon or terminology, so this is my childhood home in Florida and my elementary school in Miami. I used to bike to and from these places as a kid. So that's a real mesosystem, two real settings. Those are the kinds of things that Uri Bronfenbrenner focused on in the ecology of development. A real virtual system is, an example is this person on an airplane. It's a place moving through space, but it's a place where she's accessing a virtual setting through Wi-Fi. So that's an RV kind of connection. And you can see, similar examples, and I'll show a few other examples, but as I said, these can be complementary. That is, the virtual connection can reinforce what's happening in the place, whether it's a classroom or workplace, or they can be conflicted if they interfere with each other, or they can be more neutral. So these are sort of three categories of how these RV connections can work in terms of the valence of their outcomes, whether they're positive or negative for us. And these are some other examples. So here's a child accessing Instagram and Facebook from her bedroom at home. These are examples of RV mesosystems. And individuals can have many of these going on at the same time, which is one of the reasons that our attention these days can be fragmented in so many ways by our virtual connections in a particular place. So when people are driving, for example, and texting and try to do social media, some pretty severe major implications for well-being and safety in those kinds of settings. The size of these circles sort of reflect the psychological importance of them. So this particular adult from their office is connected to LinkedIn, Facebook, and their personal blog site. And maybe they're most psychologically invested in the blog site, so they spend more time there than perhaps on LinkedIn or something like that. And then to use Bronfenbrenner's exosystem terms, so this is a child mesosystem, RV mesosystem. She's in her bedroom connecting to Facebook, but the parent's in another room connecting to Second Life or some other website. So these are separate mesosystems, but each of these is an exosystem for the other. So, the parent isn't involved in this connection, but it may affect the parent if the parent feels that their child is holed up spending too much time on the internet, or if the child needs the parent's attention or help on homework or whatever it might be, and they're tied up, doing online banking or something. So that's a way in which these mesosystem and exosystem ideas come together. So one of the things I suggest is that it's really important to map and understand the interfaces between these different spheres of the environment. Not only are they at different levels, but our environment is multidimensional, and we need to understand how those dimensions fit together. So I look at sort of the built sociocultural linkages, the built natural environment linkages, natural social environment linkages, the cyber sociocultural linkages, cyber built environment links, and cyber natural environment links. And the cyber act turns out to have very major implications for the natural environment in terms of greenhouse gases and energy use. And I'll give a couple of examples of those. let me see how we're doing on time, because I want to make sure I leave some time for discussion. Quickly, this is an example of the physical and social environments affecting each other. Don Appleyard's work in San Francisco, where he compared in the same neighborhood heavily trafficked streets, 16,000 cars or trucks a day, moderate traffic streets, 8,000 vehicles a day, and 2,000 vehicles a day, the light traffic street. And when he asked people to draw their neighborhoods, they were much more expansive and showed both sides of the block as being their kind of comfortable neighborhood territory. But as physical traffic intrudes on the neighborhood, their idea of what constitutes their own neighborhood shrinks down, so that neighboring becomes less frequent, their sense of neighborhood space becomes more constrained. So this is an example of how the physical factor of the traffic can affect the social climate of that neighborhood. There are many other examples of how the natural and built environment interface work. So we have a rise of interest in landscape urbanism, green roofs movement, urban agriculture as a way of humanizing and making urban environments more habitable. The human and the natural environment at a broader global level. We know that plastics use coming from our different economic activities has led to these plastic patches that are circling out in the ocean, just about all oceans around the world, but this is the Pacific Ocean with 3 major garbage patches that are swirling around from our plastics and other refuse. So that's a human natural-made kind of impact. There are studies of the effects of nearby nature on the social behavior of crime. So Francis Kuo at the University of Illinois has shown that in low-income housing projects in Chicago, if people's window views are of trees and nature, there's less family violence and domestic abuse in those environments, interestingly, than if their window views are of barren asphalt, no foliage, no nature, more impaired coping and greater impulsivity, higher crime rates. So this is a very interesting kind of example of how the natural environment affects the social environment. The cyber environment, we see how it's reshaping cities through smart city designs and transitions to autonomous vehicles and roads. So the cyber is affecting our built environments in so many ways. It's also affecting our social sphere in terms of social habits, in terms of how we connect others, how we look for romantic partners, how we vote, which is a big issue these days with cyber hacking. The rise of the post-truth era because of the proliferation of false information and the erosion of our information ecology. Governance structures are threatened by that loss of information validity. The impacts of the cyber technologies on food and water infrastructures, transportation, electrical grids. So very broad impacts of the cybersphere on those issues. And as well on the natural environment, there are some estimates that cyber technologies could account for as much as 51% of global electricity use by 2030 and account for nearly 25% of greenhouse gas emissions. Those are huge numbers coming from all this cyber technology usage. And that has implications for the natural environment because we know that as greenhouse gases increase and CO2 concentrations increase, the ocean is becoming acidified. That affects the ecosystem in the ocean. So phytoplankton, which are one of the base species, they're single-celled organisms that produce half of the oxygen emissions on Earth through photosynthesis. Those are being threatened and dying off because of the ocean acidification. So we might think that sending digital messages or doing cyber searches have little impact on the natural environment, but in fact, that interface is a very important one. And there are potential ways in which we might stem that problem. In this, for example, Google estimates that a typical search using its services requires as much energy as illuminating a 60-watt light bulb for 17 seconds, and typically is responsible for emitting 0.2 grams of CO2. Well, if you multiply that by all the searches that are done each day, you get a sense of what the impact of that problem is. And there are ways of trying to stem that by creating more efficient computer chips, by creating more efficient ways to cool data centers and data servers, by using Arctic air and cold water. So there are ways to try to technologically cope, but it's a major problem that a lot of times is ignored when we think of the cybersphere as this kind of invisible, immaterial thing that doesn't have any impacts on the natural environment. Well, I do want to leave some time for discussion. This is another principle I talk about in terms of the tremendous transdisciplinary quality of social ecology, and the ways in which, we have to be aware of the various levels, if we're looking at health influences, from the genomic level and the cellular level within an organism, and then on out to the micro, meso, macro, and global spheres of their environment. So we really need to be able to train people who are able to think across scales from the genomic level, the microbiome level, the indoor bacterial macrobiome level, and finally the exposome, which is all of the influences that people are exposed to in the course of a particular period of their life, the environmental exposures that they go through. An example of why this is important is we know that for many diseases, being exposed to particulate matter, fine particulate matter from combustion in cities like LA and Mexico City, are very much implicated in diseases like diabetes, Alzheimer's disease. But if you combine that exposure to air pollution with genetic alleles like the APOE4 profile for Alzheimer's disease, that interaction between the environmental pollution and the genetic allele goes up almost 24 times. So this gets to the issue of really trying to train people for the 21st century research and practice in these sort of 4 T's that I refer to: transdisciplinary, team-based, translational, and transcultural. And here you have this small particle physics team from CERN in Switzerland, where their publications often include 2,000 authors who are working across time zones and cultures on the internet. So I think I'll stop there, and I'd like to open it up for discussion. And I appreciate all of your patience and listening in as I went through this. There are a few more slides I could show, but I really want to have more discussion now if you all would like to do that.
Well, great. Thank you so much, Dan. That was fantastic. So interesting to see kind of such rich application of these ideas and kind of the genesis of a lot of the thoughts that we have as we think of how do you operationalize these ideas. I have a question from Pips Veazey, who sent it to me in chat.
Okay.
That I wish I could take credit for, but it's not mine. It's a really good one. She asked if I would ask you what your vision of team science in the future is, and specifically, what should we be paying attention to now that we are not, and how will team science shift over the next half century?
Well, one of the, let me just go to a quick slide that I didn't show, but it's the last slide that I had. I think we need to take this multi-scale thinking and ecosystem kind of perspective and apply it to team science, or what's sometimes called convergent discovery and translation, convergent science, which is really transdisciplinary team science applied to compelling national and environmental problems, global problems. And often it involves co-production of knowledge between academics and community partners. So these are some of the things that NSF emphasizes when they talk about convergent science, but it's very much kind of looking ahead at what team science is going to look like. And this ecosystem, like just as I showed an ecosystem for sustainability, you can think of an ecosystem for team science or convergent collaboration. So there's the funding agency and the societal level. And some agencies now are requiring collaboration plans. They're requiring team science elements to a center grant proposal to show that the applicants have the capacity to do team science. There's also the institutional level, incentives for cross-disciplinary work. And so that's kind of the blue circle here, where, let's say on a university campus, you've got merit and promotion committees trying to decide on tenure. And do they incorporate considerations of contributions to collaborative science? And that's a big issue. Do they provide facilities on campus for co-located teams that are conducive to collaboration and creativity? Do they account for grants in ways that provide incentives for multiple players? So not just the lead PI gets the grant credit and the indirect costs, but they're partners from across several different schools that are participating on campus. So there are a lot of those kind of institutional level incentives. And then further down the level, okay, so you've got the team, let's say this team one here, that's maybe connected to other teams as part of a multi-team system, or they're connected to community partners in this green circle here. So how do we take the literature and the knowledge base of team science and apply it to teams so that they improve their processes, they improve their productivity and effectiveness? And there are a number of strategies that we're actually trying out at UCI as part of this ecosystem approach to promote greater synergy across these different levels of the convergent science ecosystem. And finally, there's the issue of, how do we cultivate individual core competencies in team science, whether that be a transdisciplinary module as part of a training grant, or core curricula that introduce people to systems thinking and multi-level analysis, and the ways in which different dimensions of the environment affect some of the outcomes I talked about. So really all of these different levels of the ecosystem for team science have to be addressed. And I'm giving a talk actually at the University of California Team Science Retreat in late September, which talks a little more about some of the specific ways we're trying to do this at UCI to accelerate team science on a university campus and beyond. So that's one direction I would say will probably get more and more development in the future. How do we connect these different forces or contextual influences on team science that they're arrayed in a very productive, effective way? I hope that's responsive. That's one kind of direction that I thought of.
Yeah, that's fantastic. And I, as always, love your visualization of the kind of multi-level but simultaneous parallel paths that are needed to be addressing it, both from the research and the pedagogy side.
And I should say that, this team approach, where we're trying to use a team to accelerate teamwork, I'm working collaboratively with Maritza Salazar, Judy and Gary Olson, and our Vice Chancellor for Research, Pramod Karganagar, has been a huge supporter of this effort because he would like to see team science infused into all the different things the university does, but feels that the resources of team science can be better arrayed and deployed. So he's sort of trying to, he's called upon us to try to provide some of that work. And we have other partners around the campus like Dan Cooper in the Institute for Clinical and Translational Science that has been a big promoter of implementing team strategies across the university. So I did want to call them out because they've been tremendous collaborators in this.
That's fantastic. And that institutional level support is just such a critical piece of this. So I see we have about 4 or 5 minutes left. If anyone wants to speak up, if you have the ability to click on the participants piece, little icon, you can then raise your hand, or I guess just anybody could do this, Dan. Sorry, I should have addressed. Okay. If anybody wants to click on that participants bit, you can click a raise hand button. Alternatively, just really feel free to take yourself off mute and speak up if you've got something that you would like to pose. I always like to give people a few minutes to find out where the mute button is.
Yeah, talking about technological challenges.
Right, we're in a mixed, a place-based and virtual system at the same time, right?
Yeah.
Well, I don't want to be taking up all the airspace, but I also don't want to be wasting our opportunity to ask you a question. So while everybody else might be thinking of something, I have a question for folks that are in the InterReach community who typically this little sort of subset of science of team science, transdisciplinarity, you know, all the different, as Gabrielle Bammer would call them, you know, smaller tribes of this bigger interdisciplinary community. This little subset has focused on people who are trying to do this work as really the main portion of their role. So their role, whatever it is dedicated to this interstitial work and being the connective tissue. I wonder if you could speak to how you see those types of roles advancing in terms of being, you know, not just within the system, like you mentioned, being incorporated into promotion and tenure for tenure track people who are encouraged to be more interdisciplinary, but do you see an advancement and a sort of institutionalization and evaluation infrastructure developing for people who are in these maybe administrative kind of non-traditional roles, or how do you see that evolving?
I think that it's a very fast-growing area of interest and activity. For example, this University of California, Cal State University retreat that I mentioned in September encompasses all the campuses of those two very large university systems. And often the folks that come to those workshops each year are vice chancellors for research, vice presidents for research, other administrators who are interested in kind of implementing these strategies on their campuses. And I know this is happening outside of California in many systems as well. So it seems to me quite a growth area where universities are realizing that team science and convergent discovery is extremely important and has to be cultivated more effectively. At the same time, I think we recognize that not everybody should be pushed into the same boxes. So, you know, some people are much more inclined and capable of working within a particularly disciplinary field and drilling down on a disciplinary question and being very creative and productive with that, rather than working as part of a large team. So I don't think everybody has to be in a team science mode, and even people in team science weave in and out of working on their own and incubating ideas and bringing some of that back to the group. So we're not always in team mode, and we're not always in transdisciplinary mode. Sometimes we go back to our disciplinary roots or knowledge bases and think about how that relates to our work. And sometimes we're more inter or transdisciplinary. So it's not an all-in-one thing over time. It varies over time. But I do think that science has moved from the 20th to the 21st century in a much more networked direction. So even students in our school who aren't particularly aiming to be team scientists or transdisciplinary, we like to expose them to these trends that I mentioned, you know, the 4 T's of transdisciplinarity, team-based, transcultural, translational, because those are really affecting where the many different fields are going. So there needs to be at least some portion of people working in that mode in order to take advantage of the synergies that derive from collaboration across diverse fields. But not everybody is going to necessarily want to pursue that route or be well suited for it.
That's a great point. Well, with that, I just want to thank you so much again for your time and generosity. This has been really excellent, and what a treat for us.
Oh, my pleasure. Thanks for having me, and look forward to tuning into some other InterReach sessions.
Perfect. Well, that's actually a great segue, because I think there's just 2 quick announcements we wanted to make in wrapping up this week's webinar. Is there is in our fall 2018 series, we have a September webinar on September the 11th, which will be hosting the Co-Navigator tool. It's a hands-on interdisciplinary problem-solving presentation, and it's going to be presented by 3 co-developers, Katrine Lindvig, Lynn Hillersdahl, and David Earl. And that will be on Tuesday, September 11th from 11 a.m. to 12 p.m. Eastern Time. You can always find that at interreach.org/events. And beyond that, if anybody who is on this call or anytime on the listserv would ever like to propose someone that you'd like to invite for a webinar or a discussion panel that you'd like to host, we really like to see this webinar series as just a rolling conference. It's just always available for us to talk as a community about things that are useful to us as a community. So we are putting on this webinar, but we're not the owners of the community. It's everybody who calls in. So it's for all of you. Please feel free to utilize that open platform and suggest things at any time. All right. Well, thank you everybody for your time.
Thank you, everyone. Appreciate it.
Wonderful. Have a great rest of your day. Thank you so much, Dan.
Bye-bye.
Bye-bye.